Okay, so if we have a look at our y equals x to the 5, we just sketch basically an x cubic graph. It's going to go through the point 1, x equal to 1, 1 to the power of anything is 1. So 1, 1 and negative 1, and it's got that basic shape. Now, it's easiest if we compare that to x to the 9. You'll see that it starts steeper, gets steep, and goes flatter in through the origin. So it gets flatter between negative 1 and 1 because it's a fractional power we're raising, but it's steeper once we get bigger than x equal to 1 because 1 to the bigger number, or 2 to the power of 9 is bigger than 2 to the power of 5, for example. If we've got even integers, well, they look like a parabola. So that graph there could be x to the power of 8, x to the power of 10. It could be anything. So we'll call that one x to the power of 8. And if we have a look at x to the power of 10, it starts steeper, gets really flat through the bottom, so it's almost like a U shape, and then it's rising as x is bigger than 1. So an odd power looks like a cubic function, an even power looks like a parabola. If we have a one-on graph, x to the power, we're going to have something that looks a little bit like a truncus, aren't we? So 1 on x to the n, where n is odd, is going to have a truncus look. So there's 1 on x, we can see that. But again, if we compare that to 1 on x cubed, it's steeper when x is less than 1 and flatter when x is greater than 1. Same as on the left-hand side. Okay, so the shapes are there. It's just a case of being steeper or shallower.